Hey, it's Mrs. Barnett. I'm coming at you from COVID 2020. I'm going to laugh every time I say that. We are going to continue with logarithms. I know, you're shocked. So, we're going to be able to use E to solve problems. That's our objective today. You're wondering, what's E? Well, E is an irrational number, just like pi or square root of 2. It goes on forever and ever. It's actually Euler's number, but it is 2.71828. So when we see E, it's a number like pi is when we use pi. All right? Okay, so first thing we're going to practice is solving our writing e's in logarithmic form. So when we see e to the power of x is equal to 8, just like we can change exponential form into logarithms, we can change e's into logarithms, and it's actually called the natural log. So there's a little bit of a different notation, but it's not that bad. So if we were just going to do this like anything else, it would be log base e, like patented swoop-de-doop method, log base e to the power of 8 is equal to x. So log base e to the power, or e of 8 is equal to x. And the only thing that's different is we can take this log base e part, log base e, and we get to call it the natural log, and that is the notation, the natural log. ln of 8 is equal to x. So it's just that, here, let me get it clear. It's just that ln, the natural log, that's the only thing that's changing. The 8 is equal to x all stays the same. So it's just the natural log of 8 is equal to x. So again, I encourage you, pause it, try these next three problems on your own, and then let me do it with you. Okay, I'm going to assume you paused it. So this one is log base swoop-de-doop e to the power e of x is equal to 5. It's this log base e, log e, that we get to change into the natural log. So that becomes the natural log of x is equal to 5. That's it. Okay, log base e of 9 is equal to x. This log e becomes the natural log of 9 is equal to x. And again, log e of x is equal to 7. So this log e becomes the natural log of x is equal to 7. All right, and other way around. If we see ln, we can change that into log base e of x is about 0.7741, and if I want to put it in exponential form, you guessed it, we do the swoop-de-doop method. So let's do pink. E to the power of 0.7741 is equal to x. Let's do that again in slow-mo. So the natural log, I can rewrite that as log base e. The rest stays the same. Of 10 is equal to x, and from here I can write it in swoop-de-doop, or I can use swoop-de-doop. I'm going to write it in exponential form. So e to the power of x is equal to 10. All right, pause it. Try these on your own. Don't take my word for it. Okay, I'm going to assume you paused it. Log base e of x is about 2.1438. And now to write it in exponential form, I do the swoop-de-doop. E to the power of 2.1438 is equal to x. Dunsky. Same thing. Log base e of 18 is equal to x. So e to the power of x is equal to 18. There are problems like these too on that practice. So if you want to pause the video now and go do those practice problems now, it might be a good time to do that. You never know. You could do that. It's the first 2 slides. All right, but we could continue on. So we're going to simplify these expressions. That means we're going to write it as a single logarithm. So we're condensing these logs. So we're using the same properties of x, or properties, that's the properties of exponents, properties of logs that we already have used in 10.5. So this is using the properties of logs. So first, if there's a coefficient in the front, it can become an exponent. So the natural log of 10 to the power of 3, there is no coefficient. This one's just going to say the natural log of 8. Now 10 cubed is 1,000 minus the natural log of 8. When I see this minus sign, I'm going to think division. So it's going to be natural log of 1,000 divided by 8. These two numbers are going to be divided by, or the first one divided by the second one, because of that subtraction sign. So then I'm just going to do 1,000 divided by 8. Oh, we already did it. 1,000 divided by 8 is 125. So the answer is the natural log of 125. All right, these ones are trickier over here, but we can continue on. So first we want to get rid of exponents. So this 2 is going to become an exponent. So everything else stays the same. Natural log of 40 plus the natural log of 1/2 to the power of 2 plus the natural log of x. I see the plus sign, so I'm going to multiply everything. And this 1/2, let's simplify that first. So natural log of 40 is going to stay the same. And 1/2 squared. 1 squared is 1, and 2 squared is 4. So we get the natural log of 1/4 plus the natural log of x. Now all three of these numbers right here are going to multiply together. So we're going to get the natural log of 40 times 1/4 times x. A fourth of 40 is 10, and 10 times x is 10x. That's the answer. All right, another one with both of these have exponent, or we're going to make into exponents. So the natural log of 4 squared minus the natural log of 2 cubed. Now we just have to figure out what 4 squared is and 2 cubed is. The natural log 4 squared is 16, and the natural log of 2 cubed is 8. So we're going to get the natural log of 16 divided by 8, and 16 divided by 8 is 2. All right, those are probably the trickiest problems we're doing today. So good on you, we already did it. All right, so now we're going to solve exponential equations. We're just learning using one method today, and that method means we're going to convert it into logarithmic form and then use the change of base formula, which we already learned, to solve these equations. So first we're going to put it in log form. So this is going to be, we're using the swoop-de-doop. Swoop-de-doop. Log base 4 of 19 is equal to x. These problems are different than if you had something that you knew, like if you have 3 to the power of x is equal to 9, we don't have to do this method because we know that 3 to the power of x would be equal to 3 squared, and x would just be equal to 2. That's the first method. That was review. You already know how to do this. This is if I can't raise 4 to a power to make it 19. So I'm going to use change of base to solve that problem. So this one, so I already wrote it in logarithmic form. So then it goes log of 19 divided by log 4 is equal to x. And this is when I pull out my calculator and do it. 19 log, see how my calculator does log of 19 divided by 4 log is equal to, and then so that would be my answer. X is just going to be 2.12, and then we want to go to 4 decimal places. This one goes to 12396. 12396 is equal to x, but you want to go to 4 decimal places. This 6 makes the 9 go up, and 9 is kind of tricky. It's going to be 2.12. The 9 also makes the 3 go up, so 40. So 39 would round to 40, basically. That's the answer right there. All right, that's it. So try this next one on your own, and then we'll do this 2x minus 3 together. So I hope you tried this 3 to the power of x is equal to 15 on your own. we'd use the swoop-de-doop method. Yes, Claire, go to the bathroom. Log base 3 of 15 is equal to x. And now we use change of base. So log of 15 divided by log of 3 is equal to x. You plug that into your calculator. I've already done it. The answer is 2.4650 is x. All right. So before we can write it in exponential form, we need to get this part by itself. So to get that by itself, I'm going to add 3 to both sides. So I get 2 to the power of x is equal to 15. And from there, now I'm going to write it in log form. So it's log base 2 of 15 is equal to x. Change of base, log 15 divided by log 2 is equal to x, and then you get your decimal. It's 3.9069 is equal to x. All right, again, so this is, again, just writing in exponential form. Log base 6 of 42 is equal to x. And now we're doing change of base. Log of 42 divided by log 6 is equal to x. I use my calculator and get 2.0860 is equal to x. All right, this one's a little bit different. I'm going to rewrite it so the power is on the left. And now we're going to do the same thing, swoop-de-doop. So log base 4 of 30 is equal to x plus 1. We're going to deal with that x plus 1 at the end. So we're still going to do change of base, log base 30 of over log, so log of 30 over log 4 is equal to x plus 1. I'm going to get a decimal for that. When I plug it in my calculator, it's 2.4534 is equal to x plus 1. And now, what would I do to get x by itself? I would subtract 1 from both sides. So 2 point all that stuff minus 1 is just going to be 1.4534 is equal to x. Okay, I encourage you, pause it, try this last one on your own before we do it together. Okay, we're going to write it in exponential form. In log form, log base 9 of 76 is equal to 5n. Change of base, log 76 divided by log 9 is equal to 5n. Get a decimal for that. So we get 1.9710 is equal to 5n. And if I want to get n by itself, I'm just dividing by 5. Divide by 5, and we get 0.3942 is equal to n. That's it. All right, thanks guys. Do the practice. Let me know if you have any questions. Have a great day.